So having done a little bit of geometry by this time, some basic congruences, similarity of triangles, let's move on to another very important entity, the circle. The circle, as all of you understand, is the locus of a point moving in a plane such that its distance from a fixed point is constant. That fixed point is referred to as the center of the circle. That distance from the fixed point of the moving point is referred to as the radius of the circle. Now, I don't want to waste your time by telling you what a circle is, because all along, you've read that. Let's get straight into the properties of a circle. I will assume that you know what a chord of a circle is, what a segment is, what a major arc is, what a minor arc is. Now, if you're already familiar with all of it, then let's get straight into the groove. Let's start by understanding some of the very basic properties of circles. Now, of the properties that you're going to learn, the most important and the most basic property of chords of a circle is the following. If this is a circle, let's say the center of the circle is O, and say this is a chord of the circle AB, then what we want to establish is that the perpendicular from the center to a chord, this is the perpendicular from the center to a chord OM. The perpendicular from the center to a chord must bisect the chord. The perpendicular from the center to a chord must bisect the chord. Which is to say that if AB is the chord and if OM is perpendicular to AB, if OM is perpendicular to AB, then we want to establish that M is the midpoint of AB. That means we want to prove that AM is BM. This is what we want to prove that AM is BM, given that OM is perpendicular to AB. Now, very simple. Let me join O to A. Let me also join O to B. And let me look at triangles OAM and OBM. Now in these two triangles, realize that one, OA is OB. Why so? Because they are the radii of the same circle. Clear? Both OA and OB represent the radius of the same circle. So they must be equal. 2, OM is common to the two triangles. OM is common to the two triangles. Now if OM is common to the two triangles, that means in these two triangles, two sides are equal. OA is OB and OM is common to both. And the two triangles are right angle triangles. These two OAM and OBM are right angle triangles. Why? Because angle OMA and angle OMB are both 90 degrees. They are right angle triangles. Now in two right angle triangles, if two sides are equal, OA equals OB, OM is common to both, then the two triangles ought to be congruent. So this would lead to triangle OAM identical in all respects. That means congruent to triangle OBM. If the two triangles are congruent, that's out of the RHS condition for congruency. I believe you have fond memories of the RHS condition for congruency. So OAM congruent to OBM, and therefore I can conclude that AM must be equal to BM. AM must be equal to BM. That's the conclusion. And if AM is equal to BM, that would lead to M being the midpoint of AB. M being the midpoint of AB. Right? Which leads us to the first and the foremost property of circles. If we have a chord and if I draw a perpendicular from the center to a chord, then that perpendicular must bisect the chord, right? Now, a related property which is the converse of this. That means what we next will do is we will draw from O a line joining O to the center of AB, to the midpoint of AB, and we will establish that the bisector of AB drawn from O must be perpendicular to AB, right? That means the converse of this result. The line joining O to the midpoint of AB must be perpendicular to AB. Let's see how it goes. Okay, that means the converse of this result. Which means if this is a circle, this is a chord AB, and if O is the center of the circle, and if M is the midpoint of AB, M is the midpoint of AB, the chord, then we want to prove that OM is perpendicular to AB. This is what we want to establish, right? As simple as this. Now, once again, look at triangles OAM and OBM. Now, in these two triangles, realize number one, OA and OB are equal. OA equals OB. Why so? Because they are the radii of the same circle. They are radii of the same circle. Also, OM is common to both. OM is common to both the triangles. The third, AM must be equal to BM. Why so? That's given. AM is BM because M is the midpoint of AB. Now, if these three conditions are met, then in these two triangles, this side equal to this side, AM equals BM, and OM is common to the two triangles, which means the two triangles must be congruent. What's the rule of congruency that applies here? The SSS condition for congruency. If the three sides of one triangle be equal to three sides of the other triangle, then the two triangles ought to be congruent. That means triangle OAM is identical in all respects to triangle OBM, and which would lead to this is out of the SSS condition for congruency. Just in case congruency has got wiped off your head, go back to our earlier classes and refer to conditions for congruency. Get afresh before you embark on mission circles, right? Now, if this be the case, then the corresponding angles must be equal. Angle OMA must be equal to angle OMB, right? Because the two triangles are congruent, the corresponding angles must be equal. Angle OMA must be equal to angle OMB. And then angle OMA plus angle OMB is how much? Obviously 180 degrees. See, this angle plus this angle will be 180 degrees, angle along a straight line. That's equal to 180 degrees. And therefore, if this angle is equal to this angle, and if the sum of these two angles is 180 degrees, then out of 5 and 6, out of this condition and this condition, we must have angle OMA equals angle OMB, each equal to 90 degrees. Which means, and so this is of course out of conditions 5 and 6. Statements 5 and 6 lead us to angle OMA equals angle OMB, and therefore OM perpendicular to AB. That means if from the center you draw a line that bisects a chord, then it must also be perpendicular to the chord. So this brings us to the basic result on circles. A perpendicular from the center to a chord must bisect the chord, or if a line is drawn from the center to the midpoint of the chord, then it must be perpendicular to the chord. We are going to use this result like staple food. Alright, so after this we'll set a foundation on more results related to circles. This much, wait for more. Have fun.